Hi, everyone. My name is Sierra Laverty. I'm the Assistant Horticulture Director here at the Idaho Botanical Garden. And we are going to be talking today about pests and guests, the value of conservation biological control in public gardens. And we're really lucky today to have with us Corin Pease. He's with the Xerces Society as their pollinator conservation planner for the Pacific Northwest. And just so anybody knows that's an arborist out there, you can get your ISA certification, International Society of Arborists, through this. This will be a 4-credit session for that, and the code for that will be given at the end of the session. All right, so without too much introduction here, we're going to get right into it. We are your 2 presenters. Corin has is going to be going over conservation biological control and what that means, what it really entails. And then towards the end of this, I'll be talking about how that relates to public gardens and why we really want to be focusing on that as well throughout our operations, and some techniques to do that as well. So without too much, I'm going to give one quote that's really inspiring here that I learned at a Xerces Society workshop. The greatest single factor in preventing insects from overwhelming the rest of the world is the internecine warfare which they carry out among themselves. So we want to encourage that warfare, and Corin is going to give us some tips and tricks on how to do that, and his experience from working with farmers and in more of an agriculture setting that we can then apply to public gardens.
All right, well, thanks, Sierra. So I'm going to give a quick introduction to conservation biocontrol. And I work for the Xerces Society as a pollinator conservation planner for the Pacific Northwest. And my job is to work with farmers mostly, and to help them install habitat for pollinators and beneficial insects. So the Xerces Society, quick little introduction on the Xerces Society. It was founded in 1971 as a butterfly conservation group. It's a nonprofit, and through the years, we've expanded our work into all insects, all invertebrates, really. So we do work on pollinators, endangered species, even some aquatic invertebrates like mussels. And we do also work on pesticide education, and some work on urban conservation also. So we have staff in 13 states across the US. We do training events in all 50 states, Europe, Asia, and Latin America. So we do training on habitat installation, and basic pollinator and beneficial insect biology. So what is conservation biocontrol? So you might hear me refer to it as CBC for short. So it's the practice of providing habitat for beneficial insects who control pest populations. And so it also includes limiting our pesticide impacts on these beneficial insects. And here's this quote again. I don't have to repeat it again, but I love this quote about internecine warfare going on between our different insects. So there's a broad range of different beneficial insects out there. Unfortunately, I don't have time to go into all of them today, but we're just gonna generally touch on the 2 major groups of beneficial insects that you'll see out there. So predators, of course, many of you are familiar with ladybugs, lacewings, maybe even assassin bugs, hoverflies. There's a ton of different beneficial predators out there, and some things are very common with them. They tend to be generalists, and so they feed on a variety of different prey. And so when one prey is not available, they'll often switch to another prey. And so what we call it when there's when they're feeding on a non-pest prey, we'll call that alternative prey. And so they'll feed on many different insects, and honestly, they'll even feed on other beneficial insect species. The other major group of beneficial natural enemies are the parasitoids, and there's two major groups within parasitoids are the flies in the family Tachinidae, and then the wasps in the Ecumenidae and the Chalcidoidea. So those two groups of species, they're different than the predators in that they are not as, they're specialists. So they will often specialize in one particular insect group or species. And so in this case, parasitoids will lay their eggs within other insects' eggs or in the bodies of other insects. And so those eggs will then hatch, and the larvae will then hatch out and either feed inside the egg or inside the adult or larval insect, and then emerge as adults. And in the process, they kill their host. And so they tend to overwinter in their host. Other things that are important about parasitoids to keep in mind is that they'll often persist in environments with low levels of prey. And keep in mind also that almost every species of insect out there has an associated parasitoid, at least one, maybe many. And so insects are always being attacked by these parasitoids. There's a huge diversity. And while they're not spending time inside their host, they're the adults of these parasitic species are feeding on nectar and sometimes pollen. So there are three types of biocontrol. We're going to concentrate on conservation biocontrol today, but I'll just touch on the other two types of biocontrol, which is classical and augmentative biocontrol. So classical biocontrol is often managed by government agencies. And when we have an introduced pest to the United States, scientists will often go to the native range of that pest to find the associated natural enemies that help control that pest in its native range. And so often these pests are introduced without those biocontrol agents, and so their populations expand rapidly. And so classical biocontrol is to reintroduce introduce biocontrol agents that are from the native range of the pest. Now, the problem with this sometimes is there's unintended ecological and economic consequences from introducing biocontrol agents from other regions. There's been cases of these introduced agents controlling the pest, but also then getting out into our natural areas. So government agencies quarantine these biocontrol agents now and do host tests to make sure that they're not going to affect our native populations. Augmentative biocontrol is maybe what most of you are familiar with. This is when you go online or and buy ladybugs or lacewings, and honestly, this kind of approach is a temporary measure. The goal is really not to establish these insects into the field. It's just to control the pest population as is. They'll often move on outside the area where you release them. And so because of that, many greenhouses use this approach to control pests in greenhouses, and it's less often used in the outdoors. So Xerces Society really tries to concentrate on conservation biocontrol. And this is where you enhance the habitat to promote the reproduction and survival of naturally occurring natural enemies, beneficial insects. So what are some of the benefits of conservation biocontrol? It's a great alternative to insecticides. It supports the natural ecosystem because you're creating diversity and increasing landscape diversity across the landscape. Also, reduce risk of unintended consequences, like we were talking about with classical biocontrol and, of course, pesticide use. And then this approach really has reduced management costs. It doesn't cost much to implement some of these tactics. And in addition to creating habitat for these beneficial insects, you're also creating habitat for pollinators, like our native bee populations, and also other wildlife. So pests thrive in monocultures. We see out there in agriculture, there's a lot of fields that look like this, but beneficial insects need more. And in your parks and gardens, you do have some diversity, but the type of diversity is important. So what do you want to provide? What resources are important for provide to these beneficial insects? There's two major resources to provide: food resources, so pollen and nectar from flowers, and then also alternative prey. And so alternative prey means insects that don't cause pest problems on the plants that we care about, but they're prey that allow many predators to survive during periods when we don't have prey available. And then habitat also provides shelter for overwintering. So insects can overwinter in insulated areas and be able to survive, and their populations are larger the following spring. And then, of course, this habitat provides areas where insects can survive with a refuge from pesticides. So I'll go into a little bit more detail here. So the floral resources that are beneficial for a lot of these species are pollen and nectar. And both pollen and nectar increase reproduction. So you're going to get more eggs produced, whether it's from parasitoids or from predators. And it also increases the ability for many of these insects to survive periods when there aren't prey or hosts available for these insects to reproduce or feed upon. So having the pollen resources increases their longevity. So also habitat can provide alternative prey. Here's an example of a lady beetle feeding on oleander aphids that are on a milkweed plant. And so milkweeds can both provide floral resources for these beneficials and also alternative prey. Habitat can provide shelter and overwintering sites. So things like brush piles may look unattractive, but they're a great place for many insects to spend the winter. And then in addition, rock piles. Bunch grasses provide areas in between the stems at the base of those bunch grasses that provide a great place for many insects to overwinter. In the West, lady beetles will overwinter in these bunch grasses in huge numbers. And also leaf litter is super important. We have a campaign here at Xerces to encourage folks not to blow the leaves away and collect them. We call it leave the leaves. And so it's important to leave those leaves in areas to provide this overwintering habitat, areas where those insects can survive the winter. So there are many studies that show this link between habitat and beneficial insect abundance and diversity. So habitat is really the key ingredient. So what are some of those CBC all-star plants that we want to focus on? I'll just go through a few here. There's plenty of resources online on the Xerces website and in other places. for other plants, but some of the ones that I like to focus on are yarrow, elderberry, asters of all species. Goldenrod is an excellent one. Buckwheat, there's the cultivated buckwheat variety, Faguropyrum, and then there's also Eriogonum species. Milkweed, of course, provides great larval reproductive host plant for monarch butterflies, as many of us know, but it also is a great plant for beneficial floral resources. Sweet alyssum, there's been a lot of research on this plant, providing resources for these beneficial insects. Phacelia, dill, all plants within the carrot family, dill, carrot, angelica, cilantro. So all those species are great beneficial insect plants, and of course, match the button. So in addition to providing habitat resources, we also want to think about our use of pesticides and how that use of pesticides can affect these beneficial natural enemies. So one way to do that is to institute IPM program. That involves monitoring for your pest populations, using thresholds, applying pesticides only when these populations reach these thresholds. You also want to select pesticides that are not toxic, that are toxic to a narrow range of insects. An example would be Bacillus thuringiensis, BT. It's only toxic to a small number of caterpillar Lepidopteran larvae. So that's an example there. Take a look at the label, make sure that it's has a narrow mode of action. One particular group of pesticides I want to focus on here, and that Xerces is really focused on, that's caused many problems with our pollinators across the country and across the world, is neonicotinoids. And the particular issue with neonicotinoids is that they are systemic in nature, and they can stay in the plant for 6 months or more in the plant. So if you apply a pesticide in the spring, it's going to be still there in the fall. And what the biggest problem with our pollinators and beneficial insects that are visiting flowers is that these neonicotinoids, being systemic, they are expressed in the pollen and nectar of those plants. And so those effects can be long-lasting, and they can have many effects on insects that reduce their reproduction and their ability to survive in the environment. So I'm going to go quickly through some case studies here in the agricultural context. Here's an example of some research done in California on hedgerows, and they looked at the level of level of egg parasitation of stink bugs in tomatoes adjacent to hedgerows. And what they found is that the parasitism rate was 3 times higher in fields adjacent to these hedgerows as opposed to fields with just regular weedy borders. And so that's one great example of how these insects can move long distances into areas of monoculture. Here's a case study from an Illinois Christmas tree farm. And this example is interesting because it's not actually adding habitat to the environment, but it's changing a management practice that can have great impacts on biological control. In this situation, the growers didn't mow the understory as much, and that allowed clovers and musters to grow, which provided resources to parasitic wasps of the pine needle scale pest, which is a big problem in Christmas trees in Illinois. And so those wasps help control those pine needle scales and decrease populations of those scales. An example that shows the impact of alternative hosts is in Washington vineyards. Many Washington vineyards will plant roses on the end of rows as an indicator for powdery mildew, but these roses also provide a they have leafhopper species on them that's not a pest species that is an alternative host for a wasp parasitoid that also parasitizes the leafhoppers that are a pest in the vineyards. And so having these roses along the edge of vineyards provides a habitat for this alternative host, increasing the populations of this beneficial parasitoid. One last example here, beetle banks are widely used in the UK, and beetle banks are rows of perennial bunch grasses that provide overwintering habitat to ground beetles, which ground beetles are a major predator of aphids and small insects and seeds in agriculture. And so there's a lot of research that shows that in putting these beetle banks in the UK reduced pests such as aphids and blossom midges in the adjacent wheat fields. So there's the Xerces Society has a plethora of great resources on their website. I wanted to draw your attention to some of these particular resources. We have the Habitat Planning for Beneficial Insects Guide. It's an excellent guide for conservation biological control. And then with a donation, you can get this Farming with Native Beneficial Insects book. And then also focusing on parks and public landscape areas. We have a number of different publications here: pollinator-friendly parks, pollination protection for cities and campuses, and this habitat assessment guide for yards, gardens, and parks. And this guide really helps you evaluate your landscape and determine where those areas of deficiency are in your landscape for providing habitat for pollinators, and frankly will also be good for helping design your parks and landscapes for beneficial insects. So thank you for inviting me, and we'll take it back to Sierra.
All right. Thank you so much, Corin. So why should public gardens care what's happening in agriculture? This obviously, in my mind, connects really well to what we do at public gardens. But obviously, like we have as institutions that already are doing a lot of work in conservation, plant conservation, and we can extend that work to the broader biodiversity conservation. A lot of gardens are engaged in this kind of work, maybe without even knowing it. We have ideal foraging habitat often through our diverse plant collections. Like Corin was saying, having the diversity of plant species available for foraging is key. We have access to the public and have often outreach and education opportunities that are already in place that it can extend to this kind of work that would actually impact as institutions that have a lot of clout within the gardening and horticulture world. We're able to be leaders in showing them those industries, both professional and homeowners, what this work is and how to do it well in the landscape. So we can be leaders in showing how you actually provide habitat for this very keystone group of insects. And our beneficials are already at work in our gardens. They're already doing the work for us. They're already present, and these are tactics that we can do as public gardens to encourage them further. This is one of the slides that Corin showed was us at the Xerces Society's training. This is actually the other perspective of that same training. So in 2017, our collections curator and I attended a Xerces Society training where we learned about techniques that are used in agriculture, and got the bright idea to bring that back to our public garden, which is about 15 acres here in Boise. Since then, we've been able to collaborate and help present with them about doing other trainings locally with Jessica Cruz of the Xerces Society, collaborating on how to utilize native plants in the landscape. So there's a lot of opportunities, I think, for crossover work between public garden institutions and Xerces Society. Furthermore, that spurred us on to develop an actual plan for conservation biological control on site, and kind of a policy attached to that as well that just iterates to our staff what practices we expect them to do in their operations when it comes to limiting disturbance. We created very specific habitat areas that are designed for habitat using a lot of the techniques that the Xerces Society talks about, like hedgerows, like beetle banks, etc., brush piles, all of that, and I'll show that in the next slide. But those areas are limited, so we don't are limited to staff access. So we're not in and out of there all the time, disturbing the habitat. That's a key piece of that shelter. And then we also have included in our IPM program monitoring for beneficial insects. So as we're out there monitoring for pests, we're also taking data on monitoring for beneficial insects, because we want to understand their populations. We want to understand the biology of the beneficial insects that we have on site and how we can better support them down the road. And I would advocate that that's an important piece of IPM that is often missing, is that we're not capturing data on beneficial insects as well. So we've started to do a little bit of that. And finally, in creating those habitat areas, what we've done is take in specific areas throughout the garden and use them strategically for habitat, using the principles that were mentioned earlier: beetle banks, diversity. We have 80 different plant species in this area, and we also have limited staff access as well, so that we're not disturbing that habitat. We are working on interpretive signage for this. This is an example of a Xerces Society sign, and that will be available to help with public education and understanding why we have these areas that are a little bit more messy, that have brush piles. And we've also focused a lot on staff training, so that they know, looking at saving hollow stems for winter interest, but also because those are full of beneficial insects. And we also, cut those stems down, put them in our habitat areas, so that the insects could then emerge from there. That's just one example of a lot of different operations that we use to support our conservation biological control policy, and it's something that we're proud of at the Botanical Garden here. And with that, we'll take questions as we have time, and you're also welcome to reach out to Corin and I. We're available for questions kind of offline as well. So thank you so much.
To thank our presenters, Sierra Laverty from the Idaho Botanical Garden and Corin Pease of the Xerces Society, and all of you for being a part of today's session. We're slightly over time for this session, and the opening reception is getting started. If you want to discuss this session further, please use discussion forums on the conference website. This session is approved for 0.5 ISA credit hours. The code is P as in Peter, N as in Nancy, 2161. We're also putting the code in the chat box. Please contact Tommy Rosenbluth at trosenbluth@publicgardens.org for more information. We want to thank BHS Insurance for making this opening day free to all our members, and thank you all again for being part of our very first ever virtual conference. You can click live sessions on the conference website and find the link to the opening reception there. Thank you.